So if we have a quadratic equation when a is 1, in other words, just x squared as opposed to 2x squared or 3x squared or anything like that, it's a lot easier to factorize. We're just looking for two numbers that multiply to give this number, c, and add to give this number, which we call b. Now, what I've done is, down here, I've explained why that is the case. So if we had just x squared plus bx plus c, in other words, a is 1, so 1x squared, then we're saying that it's going to factorize to give x plus something multiplied by x plus something. And I've just called these two somethings m and n. Now, if we expand out this right-hand side, we end up with this. And we can take a factor of x outside the bracket and put it strangely on the right-hand side, like this. And now we can see that that this value here must be b, and that this value, let's try that again, this value must be c. So here we can see that m plus n, this value plus this value, must equal b, and m times n, so this value times this value, is going to equal to c. It's a bit different when a isn't 1, but it's not too different to that explanation of it. So I've kind of done it already up here, but I'll do it again. So you can just look, you can pause the video and just look at that if you like, but let's, I'm going to go through it again. So we've got, this time I'm going to do a specific example, 2x squared plus 5x plus 2, and I'm going to factorize it. So we know we're going to get it into two brackets, but the two left-hand terms, they used to just always be x and x because they would multiply to give x squared. But now they need to multiply to give 2x squared. So we're going to say it's 2x and x, and we're going to add something to each one. So we're just going to call these somethings m and n again. And then we're going to expand this out. And this is what I've done over here. So 2x squared plus mx plus 2nx. And that's because the 2x has been multiplied by the n. And then we get mn. So the mn stays the same as when a is 1. So in other words, the numbers that we get here, they will multiply to give 2 again. But we don't add them to give 5. It's a bit more complicated. It's actually m times 2n add together to give 5. So now what we do is we just look at some combinations, and we can say, well, they've got to, we start off by, usually it's the easiest way to do it is just look at the number for c, and then we take factors of this value, so 1 and 2 basically. The difference is it matters which one is 1 and which one is 2. So it could be that m is 1, n is 2, m is 2, n is 1. And as it happens, a is the correct answer, is the correct option, because 1, if m is 1 and n is 2, then 1 plus 2 times 2 would be 5, and that's what b is. So this is the combination, which means we now put the value for m back into where we put that, over here. Value for n back into this one over here. Okay. And then we just have to finish solving it. So 2x plus 1 is equal to 0. Therefore, 2x is equal to negative 1. Divide both sides by 2. And we've got x equals negative a half. Meanwhile, x equals negative 2. Just because we just take away, we did that one was just like before. So those are the answers. We've got minus a half, and we've got minus 2. So I'll just pause the video. I won't stop it there, and we'll have a go at another one. So with this one, 13, we've got 5a. Now this is a little bit more, if this number here is a prime number, it's a bit easier. However, I have a little theory about how to solve it when it's not a prime number. If it's a prime number, it's always just going to be 5 times 1, right? But if it was like 4, it could be 2 times 2, it could be 4 times 1. But because it's a prime number, it makes things a bit easier. So 5 times 1. It's always going to be m and n here, right? Now, again, if we expand this out from here, you'll see that the far left-hand term is going to be 5x squared, and then we've got a second term and a third term. The far right-hand term is going to be m times n. So m times n in this case is going to be negative 4. Now the middle terms are the thing that is what makes it different, because n times x, 5x, sorry, n times 5x is going to be at 5nx. Then m times x is just mx. So now we can see that 5n plus m is going to equal to 19. So what we want to do this time, I would probably suggest doing a table for m and n, and then I'd probably do what is 5n. Okay, so we're going to be looking, we want to just start off with the factors of negative 4. So we've got 4 and negative 1, we've got negative 1 and 4, we've got 2 and negative 2, we've got negative 2 and 2. But also we could have negative 4 and 1, and 1 and negative 4. There's quite a few different possibilities, but hopefully we can see that we're trying to get 5n plus m. We could actually even do plus m. So you can go through systematically and work all of them out, or you can kind of look at it and see how many of these options you can do in your head, and then see which ones it can't be, which ones it might be, and then you're just trying to get to an option that would give it equal to 19. So yeah, so the answers are going to be minus 1 and 4, because 5n is 5 times 4, so that's 20, and then plus 1, which is in this case plus negative 1, or just minus 1, that gives us 19. So that's the option. Now what? So we've got our values for m and n. So in here, we're just going to, my working out is a bit sort of all over the place, but 5 is still 5x, and this is the key thing. Remember, it's 5x, not x, right? 5x plus, well, actually, plus negative 1, so let's just say minus 1, and then multiplied by x plus 4. So remember that it's 5x, not just x. We now need to solve it. Remember therefore that's also equal to 0, of course. Right? So what's next? All right, so we had to do basically 5x is equal to 1, and then rearranging it, we have x is equal to 1/5, or if x is equal to minus 4, and that stayed there. So these are the two different solutions. So I'm just going to share my theory, and I'm not entirely sure about this, but I'm hoping this is going to be the case. So I was talking about, what do you do if you have a is not a prime number? I wonder if we have an equation like this here. They don't seem to have one like that. So whether or not a is a prime number, I was saying that, for example, if a is 4, then you could have 2x times 2x. But I'm wondering if you just always just do 4x times 1. And so if you always rearrange it to this format, then if you did, factorizing it out would give you this. So therefore, m plus an would be b, and then m times n would be c. So I haven't tested this out. I've just noticed it. but I'm fairly optimistic that this will work. So essentially, whether A is a prime number or not, we can just treat it like it was a prime number anyway. In that we don't, like I said, it's just if it was 4, like, which isn't a prime number, we just do 4x times x instead of 2x times 2x. But I'm about 95% certain that will work. So the other thing I wanted to include before the end of the video is questions like this one here. So if you came across something like this in the exam, don't immediately jump into treating it the way that we've just treated those hard quadratic equations. The reason is because these two numbers, 10 and 12, can be divided by 2. And so what we can do is we can take the whole of the left-hand side and divide it all by 2, and we get x squared plus 5x plus 6. And the right-hand side, well, 0 divided by 2 is still 0. So if the b and c can be divided by a, then do that, because now you've just got a simple quadratic equation. And in fact, this was our question 1. So we just know it's going to be x plus 3 multiplied by x plus 2. In other words, x is equal to -2 or -3. So look out for that as a quick solution. So yeah, I think I'll wrap up the video there.